Hello and welcome to a presentation on Lab 1, Simple and or Not Circuits. This presentation is going to be a little different because I'm not going to cover any new material. I'm just going to work through a lab example. Before we get started, I just want to cover two things. In order to do this lab, you're going to have to know all of the following concepts. If you've been watching my presentations or attending class, then it should be no problem. And the second thing is I'm just going to be using Circuit.js to do the implementation. If your lab is going to be using physical components, please review all of the related material to those components. You really don't want to go and break your logic chips or improperly strip a wire and spend 3 hours debugging your circuit, because trust me, that one wasn't very much fun. And before you get started doing your physical circuit, you might also want to use Circuit.js to check your solution just to make sure you have it right. It might save you a lot of headache. And with that out of the way, we can get to work. This lab is to create a circuit that represents a 4-input, 2-output truth table. Remember that to create a logic function from a truth table, we can just go to all of the rows that output a 1 and create a term for it. So we need one term here that can be shared between the two outputs, another one here, 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 here. This one can be shared, and that's all of them. But because we have a 4-input truth table, each one of these is going to require 1, 2, 3 AND gates. And we have 6 functions, so 3 times 6 AND gates is way too many. We're going to have to do some simplification in order to create this circuit. And to do those simplifications, I'm going to be using K-maps. So remember, to fill out a K-map, we're going to be looking at the A and B values and then the C and D values for the column and then the row. So here we have 0, 0, 0, 0, 0, 0, 0, 0, and function 1 has a 1 there, and function 2 also has a 1 there. Now this is getting incredibly tedious, so let me just show you a shortcut. If we look at the C and D values that represent the rows, we see that we have row 0, row 1, row 3, and then row 2. So we notice that these two are out of order. And similarly with the columns. So when we're filling stuff out, we can go 0, 1, skip the row that's out of order here, 2, and then 3, 4, 5, skip this row, 6, 7, and then we have to skip this entire column, 8, 9, skip the row, 10, 11, and then go back to the column we skipped. If you memorize where to do the skips, you can read much faster off the truth table without having to find the column and then the row to put in the value. Now that you're an expert in filling out the K-map from the truth table, it should be no problem to get this. And now we can start doing our reductions. When looking at the first K-map, the first thing I see is this lovely column here that groups most of our 1s. And then we can follow that up with a square to get all of our 1 outputs and finish the K-map very quickly. Our second K-map, we can use a looping group like this to get those out of the way. And another group here to map all of the 1s with 2 groups as well. Now the important thing is, because we're implementing this on the same circuit, is can we share any of these groups? And we can share 1, we can share this gate right here. But can we do any better? Well, looking at the first K-map, we could group all of the corners together, and that would allow us to share that gate, like so. If we do that, then this one is no longer covered, so we'd have to make a new group, like so. If we do that, we can no longer share this gate, but luckily, we could share one here. And that covers the ones on both of the K maps and allows us to share two gates. One between the orange group and the blue group, and one between the red group and the green group. And if I write the functions out here, here we have the red group, and it can share the B0C gate here, and the blue group can share the B0 D0 gate. Meaning that from 18 AND gates, we're now down to 1, 2, 3, 4, due to the sharing and reduction. Now that we have a much more manageable circuit size, we can move on to Circuit.js or your physical lab to start wiring it. So let's go ahead and build our circuit. First thing I'm going to do is get our inputs here and get them nice and evenly spaced out, but also with a lot of room. And then perhaps most importantly, I'm going to go and label everything, including the inputs, gates, and outputs. This will make it easier for you to construct, but also a lot nicer for the TAs. Please don't give them a bunch of garbage and expect them to figure out what's going on with your circuit. So looking at our equation, it looks like the B input is going to be inverted for all of our gates. So I'll do that right now. And then our first AND gate that I'll be creating will be our B0 and C. And of course, labeling that. And then we can go and create our B0 and D0. And I think again that's our only D input, so I'll go ahead and invert that right away. Now we're going to have to use these gates later, but if I just wanted to create my F1 output, I could do so right now. And I forgot to label these. Here we have B0, D0. And here we have B0C or B0, D0. And this output is F1. Now, how do we go about sharing these gates? Let's extend this one up and attach it to an AND gate with A, so we have A B0 C. And then for our second output, we're also going to need a B0 D. Then I just need to OR those two together. that will be our F2. So here are the gates we're sharing. This one and this one. And now that I think that I've got this circuit all constructed, we can do some testing. If I look at our truth table, when everything is off, F1 and F2 should both be on. Then when D is on, F1 has a don't care, and F2 should be off. And then we should have another on with C for F1, and F2 should be off. F1 should be high, and so on. You can go testing all of the different combinations. And when you're satisfied that your circuit is accurate and complete and as pretty as possible, you can go into the File tab and Save As. If you click on that link, it'll download it, and then you can rename it to whatever your TA specified and email it to them. If they want it in a different format, you can export it as a link or as text or even as an image, or however they specified. So that should be everything for this presentation. I hope you found it useful for your lab, and I hope to see you in the next one.